Hi, let's look at some polynomial graph sketching, exercise 4D. Now, when you get asked to sketch a graph, there are certain things you should know. It doesn't mean plot it accurately in terms of like you would have done at GCSE, where you were meant to draw out a table of values and stuff. You're not meant to do that. You're meant to know something about the graph before you even start. So you might, for instance, know where it crosses the y-axis. That's very common that you know that. You might learn where it crosses here. You might even find out that it's got 2 points where the graph changes direction. We call these turning points. And if you knew that, and perhaps you knew this was a cubic graph as well, which goes up and then down and up again, then you might be able to give a pretty good sketch of the graph. So let's look at a few things. First of all, can you sketch these graphs? And you must show all the axes intercepts. Now you can do them straight away. We've done a bit of this, but notice my little comment up here. Sketch does not mean scruffy. This is a not equal to sign, if you were wondering. So this is an equal sign, so a line through it meaning it's not equal to. So can you draw these graphs? And notice I factorise them for you. Press pause, draw them, and then we'll have another look. Okay, so hopefully you've drawn them. So first of all, I'm noticing there's 2 factors, and they're both with x's in it, so I think these are both quadratics. And quadratic graphs, basically you only got 2 options. It's a U-shape, or and this one I think actually is going to be an N shape. Now I'll come to Y in a bit. Now it's a quadratic like this when it's x squared graph, and you'll notice x times x will give me x squared. When this is the reason why. Look, if I times that one by that one, I get minus 2x squared. So it doesn't matter how many x squared, but when it's like that, it's a one of them. So anyway, I think I should be able to draw it quite quickly. Because it says minus 3, it crosses at 3. Because it says plus 2, it crosses at minus 2. How easy is that? We just draw a little U shape. Now, one thing you should be aware of, having done this, is the minimum point must be, because these graphs are symmetrical, it must be just slightly to the right. You could work out that that's at a half. X equals to a half that line. The one last thing I want to do on this perhaps is that point there where it crosses, and you can do that just by timesing these numbers together. That's minus 6. This one, now you do a very similar thing. You basically spot it's a U shape, because as I said it's minus 2x squared. Therefore, when this one, this is still 4 minus 4, give me that bracket equal to 0, so it's still at 4. That crosses. It's not minus 4 because it's the wrong way around. It's a positive. And this one, well, again, you've got to change the sign. That number, but because it's 2x, you divide by that. Now that's minus 1.5, so there, minus 3 over 2. Remember what I said, this is an N shape, so it goes roughly like this. It's got to be more to the right than it is to the left, because again, that seems reasonable. That's minus 1.5, that's 4. So again, you could probably work out the midpoint, but I don't necessarily want that. What I want is that point there. And to get that, I do 4 3's. That crosses at 12. That's what I'm after. Let's see my graphs. You'll notice minus 2 and 3, and I've shown minus 6. Hits at 12, yes it does, minus 1.5 and 4. So when you draw your graphs, obviously make sure you label all those important points. So when we're sketching 2 types of sketching graphs, there are basically 2 types of questions that we're going to be asked to do. The first one is we're meant to know the shapes of certain graphs, and we're meant to know them off by heart. And the second one is where we use the roots of the graphs to draw them. There's a third one which we've seen with completing the square, where you can draw it, but we'll come to use those at other times. Now in this lesson particularly, we're going to use the sketching polynomial graphs using roots. So as I say, there are standard graphs that we need to be able to draw, and draw them straight away and maybe transform them in some way. But today we're just looking at the roots. And by the roots I mean the places where the graph might cross the x-axis. These places, 1, 2, 3 of them here, these are called the roots of the graph. Sometimes they're called solutions. That's why certain equations say solve. They might be called the x-intercepts. Well, you might just think of them as answers, but really it's all the same thing. We will need to know the shape of the polynomial graph. So I did say that this one's probably a cubic, and that's because I know about cubics. So let's have a look at these shapes of graphs. So the one that you should already know is a quadratics. That's the basic quadratics. That's y equals x squared. If it's a positive number of x squared, it's this u shape. If it's a negative, it is a n shape. Well, it's not really an n at all, but it's the best letter I could think for it. And x-intercepts, well, notice this one crosses in one place. It's very common for them to cross in two places, which we just saw. A graph that does this obviously crosses in two places. But you can also get it so it doesn't cross anywhere at all. Look, that's a quadratic. It just misses the x-axis. So that's why here it says there's either no place it crosses, one place, or two place. And number of turning points is 1, and you always get one turning point. One turning point, there it is. So that's quadratics that we've already seen, but we also get this cubic graphs as well. Now this is the basic graph. Again, this is y equals x cubed. I'm not sure you can quite read it again, so I'll just write it here. This is the basic y equals x cubed graph, which you do need to know. But they can go, this one just sort of goes up and then changes its mind and carries on going. It kind of half turns and then goes, no, forget it. This is actually called a point of inflection. This little half turn that it does. Okay. Lots of people write this with an X. You might see it with a T, a CT instead. Point of inflection. Basically thinks about turning and doesn't. But it can properly turn. Look at that. This one properly turns. And this is a positive x cubed graph. So if it's plus 2x cubed or just x cubed and some other, it might say, for instance, minus 2x squared plus x minus 8. It might be y equals all that, really complicated. But because it's got a positive x squared, I know basically it's going to go up, down, and round again. Be aware that sometimes, as I say, they just half turn. And when they half turn, but then carry on going, when you get this point of inflection, you don't get quite so many turning points. Here then, it goes down. So this is a negative one. So this might be minus 2x cubed plus 6x plus 4. I've made that equation up, but you get the idea. Don't know what that looks like, but it may well look like. It'll certainly be one that goes downwards. So the cubics that go downwards are always these negative numbers of x cubed. The rest of it doesn't really matter to the shape of the graph, other than where the turning points are. So how many places can it intercept? Notice last time it was either 0, 1, or 2, whereas now it's 1, 2, or 3. This one, what's this one? This crosses in one place. It just touches there, gets closer and closer and closer and closer, gets there, and then carries on going. But it never ever comes back again. Mainly they go up, they go down, and they go up again. So you can get 3 places. So it's not uncommon for them to do something like this, crossing in 3 places. Notice there are 2 turning points. It doesn't have to be, it can be. There's no turning points, and this point of inflection isn't really counted as a proper turning point because it doesn't turn, I suppose. It nearly turns, but doesn't bother. Notice they can do this, and that's why you can get them. So there's only one solution. There's one x-intercept. And quartics, I mentioned these in class. Quartics are x to the 4. So this is y equals x to the 4. This is the standard graph. But notice they can go down, up, or it can be an upside down version of that. And of course this is graphs which start with x to the 4, positive, plus something else. And this one would be y equals a negative x to the 4, plus something else. So they can cross now in 0, 1, 2, 3, or 4 places. Let's prove that. Here's my graph. It goes down, it goes up, it goes down, it goes up. You can clearly see it's crossing in 4 places. But it doesn't have to, you see. I mean, you can draw these however you like. It could go down, but not far enough, and then go down, and then go up. So if you get that, you can see it crosses just in 2 places. How many turning points should it have? It should have 1, 2, 3 turning points. But it could have one, if one of those is a point of inflection instead. So anyway, let's have a go at a few examples. Sketch this graph. Remember, they're not meant to be scruffy. So if I was to do this, notice x times x times x. This is really an x cubed graph. This is a cubic graph because I've got 3 x's multiplied by each other. Now where they cross, I get from the roots. The shape, I'm kind of expecting it to do that. That's what I'm expecting. So because it's got x on its own, there's no number. That means that crosses at 0. X minus 5, that's 5. X plus 2, that's minus 2. So we've got 3 proper roots. And the normal one, notice it's a positive x cubed. So it's going to go up, it's going to go down, it's going to go round. And there's the graph, there's a posh graph. Okay, next one. Sketch this graph, x minus 1, x plus 3. So if I was doing this one again, I'd be thinking to myself, well, it's going to cross at plus 1. It says minus 1, you see. It's 1. It says plus 3, so I know that's going to be minus 3. Okay, I'll try and draw this accurately. Minus 3. What's this one say? Well, this says minus, so I know it's going to be plus 5 divided by that front number. That's over 2. That's 2.5. So that's something like that. So again, x times x times x is a positive amount of x cubed. So it starts low, goes something like that. Now this one, because it crosses in a different place, I really should say what that is. It's dead easy to do. You do minus 1 times 3, that's minus 3 times by minus 5 is 15. And there it is, it actually looks like 15 as well. Notice the other points, that's minus 3, that's the 1, and that's the 2.5, which I said was 5 over 2. So you can see, you can quickly draw these graphs without too much hassle. Here's some more to draw. X squared, now these are called repeated factors. So just be aware of that, repeated. Basically you can see them twice. And when you get a repeated factor, well I know, well if it was x, I'd say to myself, well it crosses at 0. I've got a 4. Notice, and again this is a positive x cubed graph. So I think it's going to do this. Now look, watch this. There, because it's a repeated factor, it just touches the graph. Repeated factors just touch the graph, they don't pass through it. That's the turning point there. I really like those, because most people don't suss that. So x squared times x cubed gives me positive x cubed. I know it starts low, goes up, then goes down, then goes up again. That's the posh graph there. Sketch this graph. But again, I'm thinking to myself, well, right, I've got another repeated. Can you see this? X plus 3 squared. So I know it's going to repeat itself. It says plus 3, so that must be at minus 3. It's going to do that at minus 3. So again, look at this. It says 2x plus 1. That's minus a half. Alright, so it's all negatives. It's all happening in a very small space there. Now, this is my repeated one. Repeated wherever it's a squared. This is a, well, if you multiply those x terms out, that times that squared, you'll get positive 2x cubed. So I think it starts low, goes up, it's got a repeat there, so it just touches, goes in, and then through. Where's it across there? 1 times by 3 squared. That's 9. And there it is, crossing at 9. Here's another one. I don't know how many more I'm going to do. That looks very similar to the last one. Oh, it is similar, but notice I've got 1 minus x now. So if I times those together, I'm going to get minus x cubed. So this time, minus 3, again, is the magic number. We've got a 1 from there. Now I'm expecting to start here. I'm going to go there, because that's a repeated factor. And that looks something like that. And again, 3 squared times that 1 will mean that crosses at 9. Well, there it is. Sketch this one. Well, we're more or less out of time, so how about I just call that quits and we'll worry about the remaining few in the lesson. But I hope it's given you an insight as to what we are doing. There's a few backward ones to do, and that's a nice place to be doing it in class. All the best.